So today we will understand schematic diagram of 6.6 kV line. So here you can see scheme diagram of 6.6 kV converter feeder, scheme diagram of 6.6 kV bus coupler, then bus riser, then line PT, then bus PT, then motor feeder and transformer outgoing feeder. So one by one we will understand all these things. So let's understand. So let's see the general details of 6.6 kV in a single line diagram. So before going to actual drawing, I will teach you let to understand how this system works. So the system is three phase, three wire. Okay. Voltage rating is 6.6 kV. Voltage tolerance is 10%. Main busbar current is 2750. So this is important thing. Whenever you learn about circuits of single phase 6.6 kV line, you should know the voltage and current rating. So this bus bar current rating is 2750 ampere and it is 6.6 kV voltage rating. Okay. Then this is the common fault level. What will be the fault level? It is 40 kV, 40 kilo ampere, and fault withstand time is 3 seconds. Okay. So here this is a internal arc fault withstand timing. It is 40 kilo ampere for 0.1 second. Whenever there will be a fault, so the fault withstand time will be 1 second for 40 kilo amperes, and phase sequence is RYB, that is red, yellow, blue. And this you don't need to know. This is the general arrangement of the compartment of breaker assembly. Here we will see the material, what material is used in the bus bar. So I'll just show you a picture of bus bar, how it looks. Wait a minute. So here you can see bus bar. This is red, yellow, and blue. So inside the breaker compartment, you will see the bus bar over here like this. Okay. Now we will go to the original drawing. So bus bar material is copper. Okay. And this is the cross section size. So what is the cross section size? This is 10 into 100 mm. Okay. So the width is 10 mm, and the size of the bus bar is 100 mm into 3, means RYB 3 phases. It is silver plated. The joints are silver plated. So I'll show you the joints. These are called joints. Okay. Here you can see here. These are joints. These are joints. These are called joints. Where the bus bar is joined over here. Here. Okay. Now sleeve on surface. Red heat sinks shrinkable ST sleeves. Sleeves. So these are sleeves over here. Okay. These are the sleeves over here. You can see. So these bus bars are actually, they are not painted. They have been worn up with the sleeves. Now what are joint shroud PVC boots? What are joint shroud PVC boots? That we'll see over here. So these are called boots where the joint is fixed. So these are called boots. Then there will be a earth bar material. What is the earth bar material? The body of, what is the earth bar material? The body of the whole compartment is being earthed. So it is made of copper. So how earthing is done, I will show you over here in figure. See, the photo is actually not visible. Uh, we'll see this after some time. So this is all about construction. Now we'll come back to the basic protection scheme over here. So this is the arrangement of how the circuit breaker. It is a vacuum circuit breaker. You can see over here, and this is the compartment. So this is the position, how it is. This is the diagram. This is the panel diagram, how it is mounted. Now before going to the actual diagram, let's understand protection scheme over here. What are the protection used? So you will see these numbers on the drawing. This is, so you can see over here 46 is thermal overload. This is 25. That will be the name of the relay. 25, when the relay operates, that when you can see all this in the drawing over here. This is check synchronous relay. The purpose of check synchronous relay is to, when you are when you are coupling incomers with bus coupler in auto mode, check synchronous relay comes in picture, and then it is 49 relay is negative phase sequence relay. Okay, if there is a phase loss, means in three phase, out of three phase, any one phase is lost, then there will be negative phase sequence will operate over here. Then the 66 relay start per hour protection. So in some circuit breakers, there is a protection over here, start per hour protection. So purpose of the start per hour protection is, it will allow for some time, if circuit breaker trips, So only after some particular time it will allow to operate in the next time till this relay is reset. The main relay is 50 relay, that is instantaneous phase overcurrent relay. Okay. Then there is instantaneous earth fault relay. Then there is 51 number IDMD phase overcurrent relay. IDMD phase overcurrent relay, the meaning of IDMD is inverse differential mean time relay. You can understand what is IDMD. Then there is 51N, that is IDMD earth fault relay. Then comes 95 relay, trip circuit supervision relay. Means your circuit is not healthy, your control circuit is not healthy, then trip circuit supervision relay will operate. Then this 86 lockout relay, this is the main relay, 86 lockout relay. There is a problem in your circuit for any reason, then this main relay will operate. That is called 86 relay. Then this is 59 neutral displacement protection relay. This is 59 over voltage relay. If the voltage exceeds, then this will operate. This is 50 LR, that is motor locked rotor relay. If motor is stalling or motor is not, if after giving command motor doesn't rotate, then there will be locked rotor relay will operate. This is fuse failure protection relay, that is 97, and this is under voltage relay. The voltage 6.6 kV. If there is less than 6.6 kV or the voltage is 0, then 27 relay will be operating over here. So these are the relays. Now there are other some relays and switches. This is feeder protection relay, under voltage protection relay, high impedance protection relay, then breaker failure protection relay, motor protection relay, then there is lockout relay, there will be interposing relay. I'll show you what is interposing relay over here. Interposing relay is actually a, just let me see, glass, it's a glass relay. The auxiliary voltage will be 24 volt and output 220 volt. See here, this is interposing relay. So there will be, this actual relay is operated from when you get the command from the PLC. The voltage is less, it is 12 volt DC. Okay, and the output voltage is 120 volt or 220 volt AC or DC, as the case may be. So from PLC there will be low voltage to operate the relay, and to make the contact NO or NC, 120 volt relay, 120 voltage output will be over here. So this is basically a glass relay. Just let me show you the picture of this relay. Yeah. So this is the picture of the relay, glass relay over here. So the input will be 24 volt DC or 12 volt DC, and output may be output will be 120 volt DC, that is operated by the relay itself to make NO-NC contact over here. Now let's go to the drawing. So this is the 6.6 kV 2750 ampere, 50 hertz, 40 kiloampere 3 seconds, 3 phase, 3 wire copper bus bar system. Okay, so this is the bus bar system. Now let understand the single line diagram over here. So over the bus bar compartment, you will see these buses. There will be two 20-volt DC bus that is used for controlling the breaker spring charging motors or breaker protection system. Then there will be two 40-volt AC that is used for space heaters or maybe used for spring charging motors. Then there is 110-volt AC for bus PT supply. Okay. Then there will be 220-volt AC supply for UPS system. In case of failure of main power, UPS will be activated, and your protection system works on the UPS. So let's see over here. This is the breaker over here, and 800 ampere vacuum circuit breaker is here, and this is the interposing relay over here. So when there will be command from PLC, close or open command, interposing relay will activate, and from interposing relay, the output will be given to the motor coil, breaker coil, that may be 220-volt AC or 240-volt AC over here. Now then comes the protection system. This is the CT over here. There are two CTs over here. There's one CT is for protection and other is for metering over here. So over here you can see the rating of the CT. CT is 100 by 1 ampere. Means on the primary side there will be 100 ampere. The secondary side there will be 1 ampere. This is the class of the CT over here. 10 VA class 5P20. And this is the metering CT for measuring of current. So this is also a 10 VA class 0.5 0.5s seconds. So this is the relay over here. We saw over there the protection systems. Okay, 50, 40 and all it is overcurrent relay. Okay, over here this is thermal overcurrent relay. All the protection system we saw earlier, that will be in this relay. This is Siemens 7SJ66. When you search for Siemens 7SJ66, you will see all these protections inside the relay. Let me just remind you how we saw the relays over here, protections over here. Yeah. So all these protections are over here in that Siemens relay over here. Okay. This is the protection. If there is any problem over here in the circuit, the relay, any protection will operate over here, just like a fault or over voltage or over current or something else will operate over here. So after when this there will be two systems over here. One will be alarm and another will be tripping. The tripping will be going through 86 relay. This is the master relay VAJ-S23. 86 relay that will ultimately trip the breaker over here. This is the metering CT. Metering CT will measure the current, like emitters, watt meters, and energy meter are connected to this metering CT. And there are two CTs over here. For this short circuit protection CTs over is also connected over here. And there is CBCT. This is core balance circuit core balance transformer over here. That is 50, the rating is 50 is to 1 ampere. Means primary side there will be 50 a current, then secondary side there will be 1 ampere current. The purpose of CBCT is to it will measure that balance current is going through the system. If any of the phase has loss of current, then this will sense over here and it will operate over here, which will ultimately trip the circuit breaker. So we will look more about this tomorrow. Let's see if there's a little bit time over here. I'll continue. Okay, so this is a PT. When you see this symbol, this is the of PT. There is a fuse over here, 3.15 ampere. This is the rating of the fuse over here. So this is line side PT over here. This is helpful for measuring voltage of the line current, line voltage. Sorry. So this will be giving output to the incoming relay. So the rating of PT is over here. This is common rating. Everywhere you can see this same type of rating over here.